Now we're going to look at all the characteristics of the secant, cosecant, and the tangent and cotangent function. So first of all, with both secant and cosecant, they're discontinuous. Discontinuous means we've got holes or asymptotes, and we saw lots of asymptotes with secant and cosecant. The period is 2 pi over b, the same period that we saw with sine and cosine. The reciprocal does not make this b over 2 pi. The fact that secant and cosine are reciprocals and cosecant and sine are reciprocals just tells us it takes the same distance until we repeat, which is going to be 2 pi over b. Secant is even and cosecant is odd. Once again, cosine was originally an even function and sine was originally an odd function. So if I take the reciprocal, it's not going to change any of those. The domain, we have all real numbers except where we had the asymptotes. And if we write this in an equation, our asymptotes occur at pi over 2 intervals for cosine. Once you're at the first pi over 2, it's every pi unit after that. So I can't say pi over 2 intervals, but pi over 2 and then add pi every time after that. And then with cosecant, it's going to be every pi n. So 1 pi, 2 pi, 3 pi, 4 pi are where I've got domain issues, where the asymptotes occur. The range goes from negative infinity to 1, actually from negative 1, union with 1 to infinity. And that's going to be the same for both of them, going from negative infinity to negative 1, union with 1 to positive infinity. And we do include 1 and negative 1 as those endpoints. The symmetries, if we have an even function, it's around the y-axis. If we have an odd function, it's around the origin. Zeros, we said there were no zeros. There are no x-intercepts. And then finally, the equation for the asymptotes, we use that in the domain, where it's every pi added from or subtracted from pi over 2 for secant, and then it's every pi units for cosecant. The second portion here is then going through the same thought process with tangent. And with tangent, we want to think of tangent as being the sine of x over the cosine of x. Or when we get to the cotangent, it'll be the cosine of x over the sine of x. So where do we get undefined points on the graph? It's going to be when the denominator equals 0, or for tangent, when cosine of x equals 0. Where do we get x-intercepts? The x-intercepts occur when the numerator is equal to 0. Or in this case, it'll be where the sine of x is equal to 0. Where does the function increase or decrease? This function increases as we go from left to right, and we'll see that on our graph in a moment. And what quadrant is tangent positive or negative? It's positive in 1 and 3, and negative in 2 and 4. And that comes from our All Students Take Calculus. Characteristics of tangent, going to be discontinuous, because we're going to have asymptotes. Right here we've got undefined points where cosine of x is equal to 0. The period's a little different than all the others. The period for tangent is going to be pi over b. Both tangent and cotangent are odd functions. The domain are going to be all real numbers except for our asymptotes. And as I said here with tangent, it's where cosine equals 0. So where all the values at cosine equals 0, it's n pi plus pi over 2, which we talked about in the previous section. Cotangent then is going to be where the denominator equals 0 once again, and for cotangent it's cosine of x over sine of x. So we're talking about where sine is equal to 0. So it's going to be all real numbers except for pi n, because that's where sine is undefined. The range for tangent is all real numbers, negative infinity to infinity. The graph gets exponentially larger along the asymptotes, goes up forever. Since these are both odd functions, they reflect around the origin. Zeros, we said, are when the numerator equals 0. So for tangent, the zeros occur every pi n units because the numerator is sine. And where do sine zeros occur? They occur every pi n. And then cotangent is where it's cosine in the numerator. So it's going to be pi n plus pi over 2. And then the equation for the asymptotes is going to be the exact opposite. Zeros became asymptotes, asymptotes become zeros. And there's all our characteristics for tangent and cotangent. Once again here, tangent of x is the sine of x over the cosine of x. The cotangent is the cosine of x over the sine of x.